All right, let's jump right into this explainer. Today we're unpacking Module 3 of the AI and Automation Masterclass, and I gotta tell you, I am absolutely thrilled about this one. We are shifting gears entirely today. We're moving away from those simple, conversational chatbot instructions and stepping into the big leagues, deterministic, enterprise-ready cognitive frameworks. Basically, this is all about how we take absolute control of large language models and structure them for maximum, highly reliable output.
So the module hooks us right out of the gate with a really fascinating question. How exactly do we force a language model to stop guessing and start reasoning? Because to truly master this technology, we kind of have to rethink LLMs entirely. They aren't just magic conversationalists, right? They are raw computational engines. And like any massive engine, they require really rigid structural scaffolds to perform complex, multi-step tasks without just totally veering off track. Okay, here is our roadmap for today. We'll kick things off with the cognitive shift in AI behavior. Then look at structural frameworks like COSTAR and ERA. After that, multi-step reasoning, grounding with few-shot alignment, and the really wild concept of meta-prompting. Finally, we'll tie the whole shebang together with a real-world execution on cybersecurity logs. Let's dive into Section 1, the cognitive shift. Before we write even a single line of a prompt, we really need to understand the fundamental processing behavior we're actually trying to change inside the model. Think about human cognition for a second. We have System 1 thinking, which is fast, automatic, intuitive, and then we have System 2 thinking, which is slow, deliberate, and highly analytical. Well, by default, LLMs operate almost entirely in System 1. They're autoregressive. That just means they guess the next most likely token in a sequence, left to right. That makes them super fast, but it also makes them incredibly hallucination-prone. So the core goal of advanced prompt engineering is to mathematically and structurally force the model out of that intuitive System 1 guessing and push it into a deliberate, analytical System 2 planning mode.
But as we build out these complex AI systems, they've got to be anchored in reality. And that brings us to a foundational concept pulled straight from recent security cooperation research, the bookend philosophy, or start human, end human. The idea here is that the AI is used for the heavy, complex processing right in the middle, but human judgment? That has to initiate the problem definition with the proper context. And human accountability must absolutely always validate the final decision. The AI is a cognitive tool, you guys. It's not an autonomous decider.
Moving on to Section 2, structural frameworks, COSTAR and ERA. So, to actually achieve this cognitive shift in a practical way, we use external structural scaffolds. Why? Because structure dictates output. One of the absolute best scaffolds for this is the COSTAR framework. By explicitly laying out these 6 semantic blocks, we're basically creating strict operational boundaries. You give the model the context or background, the exact objective, the style and tone it needs to adopt, the specific audience it's speaking to, and, crucially, the precise response format. You aren't just asking it a question anymore. You're programming a behavioral envelope that the model literally cannot step outside of. Similarly, we have the ERA framework. That stands for expectation, role, and action. This one is incredibly useful for targeted, outcome-oriented direction. You tell the AI exactly what the expected performance metrics are, you assign it a highly specific role, like say, senior security auditor, and then you give it the explicit actions to execute. This totally minimizes those annoying off-target responses and drastically enhances the model's focus on your actual business objective.
And you know, this illustrates exactly why these strict frameworks matter way beyond just getting a neat answer. Depending on where an LLM is developed, say the US versus China, it carries underlying training data variables and distinct inherent biases. Plus, using external cloud models brings up major data sovereignty concerns. By relying on rigid deterministic prompting frameworks like COSTAR, organizations can actually force localized objective outputs. You basically mitigate the variables of whichever underlying model you happen to be plugged into. You control the logic, not the model's latent training variables.
All right, Section 3, multi-step reasoning, CoT and ToT.
Now that we've got our structural scaffolds in place, let's look at the dynamic algorithms that unlock computation during generation. This is where we really push the model into that analytical System 2 thinking. First up is chain of thought, or CoT. This forces the model to generate intermediate reasoning steps, basically making it think out loud before it gives you an answer. But it's a single linear path. Enter tree of thoughts, or ToT. This takes things to a totally new dimension. Instead of one single path, ToT fires up multiple alternative reasoning branches simultaneously. It lets the model explore different avenues, evaluate them, and actually backtrack if a path starts looking wrong. It's navigating a massive combinatorial problem space all on its own.
Let's break down the architecture of a tree of thoughts into 4 steps. First, thought decomposition. That's breaking the problem into coherent language sequences. Second, generating potential thoughts for the next step. Third, doing a heuristic evaluation to measure the promise of those different states. And fourth, using search algorithms to explore the most promising branches, mathematically mapping out the best path forward. To put that into perspective for you, in a really complex math and logic puzzle called the Game of 24, standard chain of thought solved it just 4% of the time. But Tree of Thoughts? It achieved an astonishing success rate of 74%. That is a monumental leap in reasoning capability.
Okay, Section 4, Grounding with Few-Shot Alignment.
So, we have our structural blocks, we have our reasoning paths, but how do we anchor this whole engine to specific enterprise standards before we hit execute? We do that through few-shot grounding. By providing just a few high-quality, explicit input-output examples directly inside the context window, the model gets perfectly aligned. You are defining the exact syntax and schema you want. And studies actually show this allows the model to override its own flawed semantic priors and perform in-context learning. It grasps entirely new tasks without needing any expensive parameter updates or fine-tuning. It is hands down the ultimate tool for immediate, high-fidelity structural alignment.
Moving to Section 5, Meta-Prompting, AI Architecting AI.
Get ready for a real paradigm shift here. What if we just delegate the prompt engineering itself to the LLM? Recent research by Zhang and colleagues describes a metaprompt as an example-agnostic, structured prompt designed to capture reasoning structure. The profound realization here is that metaprompting isn't actually about the content at all. It's about giving the model high-level templates that tell it how to approach a task. We're leveraging the LLM's own vast language fluency to have it write its own perfectly structured instructions.
And this creates what is known as a recursive meta-prompting loop. It is genuinely mind-blowing. Step 1. The AI acts as the architect, and it generates an optimized execution template for a specific problem. Step 2. The AI then turns around and executes the downstream task using the very template it just built. This self-correcting loop basically turns the LLM into a master planner. It continually refines its own reasoning process, reducing the tokens needed while maximizing accuracy on some incredibly difficult reasoning benchmarks.
Let's wrap up with Section 6, Real-World Execution on Security Logs. Okay, let's slow down for a second and bring all of this high-level cognitive theory down to the ground. In an end-to-end workflow for automated log analysis and incident response, a 2-tiered LLM system is incredibly effective. Think about it. Logs flow in at high velocity, right? The Tier 1 triage LLM is the fast screener. It uses these structured frameworks we talked about to flag anomalies or critical events. If it flags something, it escalates it to a Tier 2 investigator LLM. This second tier has a massive context window and correlates multimodal signals, like surrounding logs, CPU metrics, deployment data, before it ever pages an on-call human engineer. Let's take a look at a Tier 1 prompt using the COSTAR framework on a raw log snippet. Say it's indicating a critical SSH root login failure from an unauthorized node. The target domain? Cybersecurity. The objective? Extract metadata and assess the threat. The style? DevSecOps Automation Engineer, meaning completely analytical, zero conversational filler. The tone is strict and alerting, and the audience is an automated SIEM pipeline parser. Do you see how everything is tightly constrained?
And here is the R in CoSTAR, the response. A strict output schema is absolutely mandated. The format demands minified JSON with exact data types for the IP address, the severity, and a Boolean for whether action is required. This explicitly forces the LLM to strip out all of its natural inclination to be chatty, returning pure, highly structured data that a downstream machine can instantly read. No fluff, just the facts.
But here is the final, absolutely critical engineering constraint. When LLM outputs are piped directly into enterprise systems, pure, raw text stream returns must be enforced. That means instructing the model to generate absolutely no markdown wraps. Actually, let me emphasize that. No backticks and no JSON text surrounding the data. If an LLM decides to be helpful and formats the JSON with Markdown, it will instantly break the downstream ingestion engine during a critical cyber incident. Precision at this level is just non-negotiable.
So this masterclass lays out some incredibly powerful scaffolds, right? Taking the LLM from a simple guessing machine to an optimized, highly structured reasoning engine. But it all comes back to that first principle. We can architect the perfect pipeline based on these tools, but are you prepared to make the final human decision? Start human, end human. These frameworks just make sure the middle is operating at maximum output. Thanks so much for joining me for this explainer. I'll see you next time.